Claude Code uses the Anthropic TypeScript SDK to make API calls to Sonnet and Opus. As I mentioned in the first Web Dev Chronicles, these API calls can be cancelled with an abort controller. The SDK has a method called fetchWithTimeout that uses this abort controller pattern. If there is an abort signal defined, the SDK attaches an event listener for the abort event to the signal object. Then it creates a timeout instance to abort the request after some time. Do you see the problem? There's more than one. Let's look at the first line. It creates a new event listener. It also creates a closure. In JavaScript, whenever you create a function, the references to the surrounding state of that function, also known as its lexical environment, are also bundled together in a closure so that the function can access its outer scope. For example here, the processValue function has access to value in the outer scope thanks to its closure. Back to the Anthropic SDK code. The event handler captures the surrounding closure scope, which includes the request body and a bunch of other objects. It might look like it shouldn't because it's declared inside the add event listener, but actually, that doesn't matter. The closure captures the lexical scope, which means the scope where the controller object exists in. Now, every time an API request is made, the objects in the outer scope are captured, and storage of these objects isn't for free, so the program consumes more and more memory. You might be asking, well, what about the garbage collector? Shouldn't it clean up the objects from memory if they're not in use? It's a good question, and normally you'd be right, but the problem is the garbage collector can't. Why? Garbage collection in JavaScript is based on the reachability of an object. The rule goes like this. An object is kept alive if it is reachable from a GC root. What's a GC root?
A starting reference that the garbage collector treats as always reachable, like a closure.
In this case, the listener holds a strong reference to the signal object. As it turns out, this listener is never removed, so each API call that goes through the SDK permanently leaks memory, since the signal can't be garbage collected. So what's the fix? Let's start with the closure problem. We don't need to create a closure here. We can use the bind method that exists on all functions in JavaScript. Bind creates a new bound function that, when called, calls the controller's abort function. The key difference here is that no lexical scope is captured, only the function reference itself and the bound this value, which is the object that abort is attached to, in this case, abort controller. The next optimization is to clean up the event listener after it has been triggered. We can do this easily by passing once true in the options object. Once the request times out, the listener is cleaned up. Now, if you remember the setTimeout from the code earlier, it was redeclaring the same function that was just created above as a bound function. So we can just reuse our bound function inside the setTimeout as well. In a small code base, you would never realize the memory leak, but in a large system like Claude Code, where this code is on the hot path, with requests getting called hundreds of times in a single session, the memory leak starts to show. But how did they even know where to look? The codebase is huge, so how are these two lines pinpointed as the problem? Well, in Node.js and Bun, you can capture the heap snapshot of your program. Then it's just a matter of looking through it or passing it to your favorite LLM to see what objects are taking up the most space. And there you have it. Stick around for next week where we look at the internals of your favorite coding agent's file system.